Across the United States, from the rugged terrains of Alaska to the tropical landscapes of Hawaii, the Earth is flexing its immense power, a reminder of the dynamic forces constantly shaping our world. This raw energy is capturing public attention with a series of notable volcanic events unfolding throughout July. From the majestic peaks of Washington to the remote regions of Alaska, the volcanic landscapes of Hawaii, and the often overlooked Cascade volcanoes of Oregon, the ground has trembled beneath our feet, a subtle yet powerful indication of the geological activity occurring deep below. And in certain areas, the Earth has glowed with molten rock, a fiery spectacle that underscores the volatile nature of these geological hotspots, sparking both fascination with the planet's power and understandable concern about potential impacts. Dramatic headlines splashed across news outlets and the rapid-fire speculation on social media platforms have collectively painted a picture of a nation on edge, closely monitoring every tremor and plume of smoke. In times like these, a grounded scientific perspective is absolutely crucial for understanding the true nature of the situation. The U.S. Geological Survey, a leading authority in this field, reassures us that, while these volcanoes are indeed active and warrant continuous vigilance and monitoring, there is currently no indication of an immediate, widespread danger to the general population. In this video, we'll embark on a journey to each of these significant volcanic regions, carefully explore the specific events that have unfolded, and hear directly from leading experts and volcanologists who can help us separate well-founded facts from unfounded fears. This is not a sensationalized story of impending doom or catastrophe, but rather a compelling narrative of a planet in constant motion and geological transformation, and the remarkable scientific advancements and monitoring systems that work tirelessly to keep us informed and safe. Mount Rainier, a majestic peak towering over Washington state, is usually a symbol of serene beauty, a breathtaking vista that draws visitors from around the globe. Its snow-capped summit and lush green slopes paint a picture of tranquility. But in early July, this iconic landmark stirred with unexpected activity. It experienced its largest ever recorded earthquake swarm, a flurry of seismic events that caught the attention of scientists and residents alike. Over 300 small, deep tremors were detected beneath the mountain's surface. These weren't your typical earthquakes. They were subtle, yet persistent vibrations that painted a unique picture of the geological processes at play. This unusual seismic activity signaled potential changes deep within the volcano's internal plumbing. It suggested that something was shifting and evolving far below the surface, prompting further investigation. For scientists, this swarm is a critical clue, an opportunity to gain valuable insights into the inner workings of this potentially active volcano and refine their understanding of its behavior. The tremors could indicate magma movement, as molten rock forces its way through underground channels, or the shifting of hydrothermal fluids, as water interacts with the hot volcanic rock. While intriguing, the earthquake swarm is not currently considered a sign of imminent eruption. Scientists emphasize that Mount Rainier is being closely monitored, and there's no indication of an impending volcanic event. The real danger at Rainier, and what makes it particularly hazardous, is its extensive glacial cover. These massive ice formations hold a significant amount of water, posing a unique threat. An eruption, even a relatively small one, could rapidly melt these glaciers, triggering devastating mudflows, also known as lahars. These are powerful torrents of water, rock, and debris. These lahars could surge down the mountain slopes, threatening nearby communities and infrastructure with little warning, underscoring the need for preparedness and mitigation strategies. For now, the mountain is quiet, its majestic peak standing tall against the sky, a picture of serene beauty. But beneath the surface, the watchful eyes of scientists never rest, and monitoring continues around the clock, providing crucial data for understanding the volcano's behavior. Scientists use GPS technology to precisely track any ground deformation, which could indicate magma movement or changes in the volcano's structure. They also conduct gas sampling, analyzing the composition of volcanic gases to detect any changes that might suggest increased activity. And of course, they rely on seismic data, constantly monitoring for earthquakes and tremors that could provide early warning signs of potential unrest. All this data is carefully analyzed to watch for any changes in the mountain's behavior, ensuring that communities are kept informed and prepared. The recent activity serves as a stark reminder of the powerful, hidden forces constantly at work beneath the Cascade Range, a chain of volcanoes stretching along the Pacific Northwest. It also underscores the critical importance of constant vigilance and scientific monitoring in safeguarding communities that live in the shadow of these potentially active volcanoes. Mount Rainier's story is a compelling one, a tale of breathtaking beauty, a reminder of the raw power of nature, and a testament to the vital role that science plays in understanding the risks and helping to protect those living in its shadow, ensuring a safer future for all. In Alaska's remote Aleutian Islands, Great Sitkin Volcano has been erupting steadily, with lava slowly filling its summit crater. The Alaska Volcano Observatory maintained a watch alert, but by July 10th, activity had decreased enough to lower the risk level. This is typical for the Aleutians, part of the Pacific Ring of Fire, where subduction drives frequent volcanic activity. Great Sitkin's eruptions are gentle and pose little threat to people, but ash clouds could endanger aircraft flying between North America and Asia. That's why observatories monitor these volcanoes closely, providing critical information to keep air travel safe. In Alaska, volcanic activity is business as usual, a powerful reminder of the forces shaping our planet. Even in remote places, science keeps us connected and protected. On Hawaii's Big Island, a geological marvel unfolds. Kilauea remains one of the world's most active volcanoes, a testament to the Earth's raw power and dynamic nature. Its fiery displays are a constant reminder of the forces shaping our planet. For decades, Kilauea has been erupting almost constantly, a near-perpetual display of volcanic activity that captivates scientists and onlookers alike. This consistent activity provides invaluable insights into the inner workings of our planet. Early July brought spectacular lava fountains, shooting molten rock high into the air in a breathtaking display of volcanic power. These fountains illuminated the night sky, showcasing the volcano's intense energy. But by July 9th, the dramatic phase ended, the towering fountains subsided, and the immediate threat diminished. Though the intense eruptions have ceased for now, a subtle glow still lingers in the crater, a persistent ember hinting at the molten activity beneath the surface. This gentle light serves as a constant reminder of the volcano's potential. Kilauea's eruptions are driven by a deep mantle hotspot, a plume of superheated rock rising from deep within the Earth. This hotspot is the engine that fuels the volcano's continuous activity. Unlike volcanoes formed by tectonic collisions, Kilauea is a shield volcano, characterized by its broad, gently sloping sides. This unique formation is a direct result of the low-viscosity lava that flows from its vents. The volcano's activity is both destructive and creative, a dual nature that shapes the landscape and influences the lives of those who live nearby. It's a constant cycle of destruction and renewal. As lava flows into the ocean, it cools and solidifies, building new land and extending the island's coastline. This process of land formation is a powerful demonstration of the volcano's creative force, constantly reshaping the island. For Hawaiians, Kilauea is sacred, a place of deep spiritual significance, woven into the fabric of their culture and traditions. It is the home of Pele, the revered goddess of fire and volcanoes, a powerful deity who embodies the creative and destructive forces of nature. And scientists work closely with communities to ensure safety, monitoring the volcano's activity, and providing crucial information to help residents prepare for potential hazards. The cycle of eruption and calm is an integral part of life here, a rhythm that shapes daily routines and fosters a deep respect for the power of nature. Continuous monitoring allows people to live alongside this powerful force, providing early warnings and enabling informed decisions that protect lives and property. Kilauea's glow, whether subtle or spectacular, is a constant reminder of Earth's creative energy, a visible manifestation of the planet's inner fire. Here, science and culture work hand in hand, fostering a deeper understanding of this dynamic landscape and ensuring the safety and well-being of the community. With volcanoes active in Washington, Alaska, and Hawaii, it's tempting to think they're all linked, but science says otherwise. While the Pacific Ring of Fire connects many volcanoes through tectonic activity, each system operates independently, with its own magma and rhythm. Hawaii's Kilauea is different still, fueled by a mantle hotspot, not plate boundaries. The timing of recent eruptions is likely coincidence, not a chain reaction. Large earthquakes can sometimes trigger nearby eruptions, but the current events are too small and too far apart for that. What we're seeing is a fascinating alignment of independent volcanic cycles, a testament to Earth's diversity. Our best defense against volcanic hazards is knowledge. powered by a nationwide network of observatories and experts. Seismometers, GPS, satellites, and gas sensors provide real-time data, allowing scientists to detect the earliest signs of unrest. When activity increases, alerts are issued using a simple color-coded system, helping communities prepare and respond. This monitoring saves lives, turning unpredictable natural forces into manageable risks. Federal support ensures these efforts continue, making science our shield against disaster. We can't stop eruptions, but we can be ready, thanks to the power of observation and communication. As we've seen, the U.S. is geologically active, but the key message from July's events is reassurance, not alarm. Mount Rainier's earthquake swarm, Great Sitkin's gentle eruption, and Kilauea's glowing crater are independent events, not signs of a looming catastrophe. Robust monitoring by the USGS and partner observatories means we're prepared, with early warnings and clear communication. The science is about protection, not panic, giving us time to act if needed. The Earth will keep shifting and erupting. Our job is to understand, respect, and live intelligently with these forces. There's no immediate danger, but the watch continues, and our knowledge grows. We're privileged to witness Earth's power, and to have the tools to stay safe.